Good evening, ladies and gentlemen. Tonight, we're going to be talking about Compose meets CameraX. My name is Ishmael, and I'm an Android engineer at Luno. I'm going to be co-presenting tonight with Maia.
Yes, so hi everybody, I'm Maia. I also work at Luno. I'm also an Android engineer with Ishmael is my colleague at Luno. And you can see our Twitter handles on screen if you need to ask us questions before or after. And also we'll be publishing the slides and the Git repos on our Twitter if you need that at the end of the talk.
Just to tell you a little bit more about myself, the most important thing you need to know about me tonight is that this is my first Tech Talk. So I'm very excited. Wish me luck and go easy on me on the questions. So we're going to look at how easy it is to use CameraX, as well as how easy it is to build it into an app that uses Jetpack Compose. So this first section of the talk will focus on CameraX. So let's take a moment to just look at who can benefit from this talk. So anyone who's considering building an in-app camera, anyone who's used camera APIs and is considering migrating to CameraX, and anyone who's curious about CameraX. So say you have a simple use case to take a picture and do something with it. There's two main options you can follow. You can use the stock camera. That's you basically use intents to launch the stock camera and then use that to take the picture. The nice thing about this is that the stock camera usually works well with the device it comes on. It's very well tested, and you would have a lot less lines of code to write to get this working. The other option is to use any of the camera APIs. There's three of them. There's Camera API, Camera 2 API, and CameraX. So this is an option you might want to take if you want to do more customizations on your camera. So let's briefly look at the older APIs before we delve into CameraX. So the first camera I'm going to talk about is Camera API, which is the oldest camera API. And I thought a nice way to look at it would be to look at it in terms of pros and cons. So the nice thing about the oldest camera API is that it's easy to use. It's supported on almost all devices, and it works really, really well with many devices. The disadvantages to this camera API is that, well, yeah, it's deprecated. So if you are building a camera, you probably don't want to use a deprecated API because obviously there might not be support for that in future. So the behavior of this camera API is inconsistent across devices. And part of this problem exists because of the fragmentation in Android. Different makes tend to do different things with their camera and allow different things. In my experience working with this API, I encountered this problem when a Huawei P20 device simply didn't want to save images correctly. So consequently, I had to write code that was specific to this device. And this apparently happens a lot on this camera API. It also has limited capabilities. So it doesn't give you access to the full capabilities of the device camera. So if you want to do something very advanced, this is definitely not the best camera API to use. It's also not lifecycle aware, so you have to include code that manages the the camera, the closing of the camera and the opening of the camera throughout the different stages of your fragment or activities lifecycle. The next camera API after that one is Camera 2 API. This is not the most creative name. So part of why this camera API was built was to give the developer more control of the camera. So this camera API basically allows you to access the full capabilities of the device camera. I hope you're noting the relative size of the pros and cons columns across the different APIs. So the disadvantage of this particular camera API is that it's got a minimum API level of, it's supported on minimum API level 21 and above. So if you happen to have, if you happen to support devices that are lower than API level 21, you might have to actually include the older camera API as well. HAL3 HAL3 support is also required for this API. That's basically the latest hardware abstraction layer. And there is different levels of support for HAL3 as well. So consequently, what that means is that depending on what you are doing with the camera API, or what you are doing on your app, or what your use case is, you might have to have logic for specific devices. There's also a whole lot of boilerplate associated with this camera API. So if you have a very simple use case that involves simply just showing the camera feed or taking a picture, you end up with a whole lot of boilerplate just to do a simple thing. This isn't very good at all because it means you have a lot of code, which makes your code more prone to errors. The learning curve for this camera API is quite steep as well. Much the same as its predecessor, this camera API has inconsistent behavior across devices. I've also worked with this API, and in my experience working with this API, we had a particular device that passed all the support checks. That's your minimum API level as well as the hardware abstraction layer support. But the device camera simply didn't work. So we had to fall back to the old camera API for that particular case. So yeah, this is something you definitely come across while working with this APIs. Again, it's due to the fragmentation on Android. It also has no lifecycle awareness, so you have to close resources. You have to basically close the camera and open the camera when your fragment or activity resumes. So let's take a look at CameraX. What is CameraX? CameraX is a Jetpack support library for building an in-app camera. So yeah, let's immediately look at the pros and cons to compare to the previous APIs. So the nice thing about working with CameraX is that it's backwards compatible all the way up to 21, API level 21. And this is the case because it basically leverages Camera 2 API. So you basically have much the same capabilities, the advanced capabilities in Camera 2 API, and some of the limitations as well. The really nice thing I found from trying out CameraX was that it's really, really easy to use compared to both the previous camera APIs. There isn't a steep learning curve at all, so you get the hang of it quite quickly. There's a lot less code you have to put up with, a lot less boilerplate. So this makes your code nice and readable, and it makes it less prone to errors. The really unique thing about this CameraX API is that it offers a consistent experience across devices. And this is the case because Google has basically set up a test lab where they test CameraX API across different devices, different makes, different models. And yeah, this is really, really nice because yeah, it means you don't have to worry too much about writing device-specific code for some odd behavior. This does not, however, mean that you shouldn't be doing rigorous testing on your camera app. You should be doing rigorous testing across as many devices as you can. But it just gives you some comfort to know that Google has also done the work for you. One other really unique thing is that this is the only camera API that is lifecycle aware. So you don't need to worry about releasing the camera and opening the camera through the various lifecycle phases of your app, or of your fragment and activity. So the only advantage is that still, like its predecessor, it's supported from API level 21. So if, again, you are building for devices less than this API level, you'll probably have to include the older API. So let's look at some code. How do I get this up and running? We actually tried this out, followed the code labs, and it was relatively easy to get this up and running. Like I said, there isn't a very steep learning curve. Now, the first thing you have to do to get this, CameraX working, is you would have to include the relevant dependencies, of course. After that, you then have to set up permissions in your manifest. So that's basically because it's Android policy to ask user permissions before accessing a resource like the camera. You also need to think about the use case of your app. If the camera is central to the use case of your app, you probably might want to block devices that don't have a camera from even downloading your app at all. The next thing you would have to do is handle user permissions. And yeah, that's basically checking that permissions is granted and allowing the user to grant permissions if the permissions are not granted. You also need to think about what you are going to do or show the user if the user doesn't grant you access to the camera. So once you've got all that going, to get the camera started, the first thing you need to do is choose a camera. Most devices will have a front camera and a back camera. But there is the option to also use an external camera. Some devices allow for that. So yeah, that's definitely also a possibility. The next step would be to prepare your target surfaces. Your target surfaces, that's basically where the output of your camera is going to go. So typically you have the preview surface, that's the camera feed that you will see on your screen. And then the image capture, where basically the raw image is saved. That's one other target surface. Another target surface could be your image analysis if you want to do more advanced stuff like computer vision or some sort of machine learning. Once you have done all of that, you will need to create an instance of the camera provider. And this has a nice method, bind to lifecycle, that basically allows you to do just that, bind your camera to the lifecycle of your activity or fragment. And all you do is include the lifecycle owner, the camera that you selected, and all your target surfaces. Once you do all that, your camera will be started. So to take a picture, you basically grab that image capture object we created before. You pass in output options that basically defines where you're going to save your file. And then you have a callback that shoots off if an error occurs or once the image is saved. And in a nutshell, that's how easy it is to get CameraX going. So what did I learn from this experiment and playing with CameraX and actually trying to code it? Well, yeah, the first thing is that, yeah, if you really want to build a camera, just use CameraX. Google advises that you use CameraX, and I'm also basically doing the same. That's because it's obviously a lot simpler, and it deals with a lot of the disadvantages and issues that you find in the older camera APIs. Are older APIs still useful? Yeah, I think they are. Particularly in a case where you want to target devices that are lower than API level 21. And if you really do some advanced stuff in with your camera, CameraX should be able to allow you to do all of that quite quickly. I have included some links and resources somewhere within this presentation if you want to learn more, or just have a look at some samples as well. I'm going to hand over to Maia for the next part of the talk.
Hi, everybody. Let me get my screen share going. Right. So I'm going to talk about the Jetpack Compose integration part of this. And as anybody who's been watching the Twitter feeds and the news has seen, Jetpack Compose is now officially 1.0 stable, so we're not in beta anymore. So hopefully we'll get our dependencies sorted out. So what is Jetpack Compose? Just briefly, it's a new UI toolkit, a declarative UI toolkit that Google has given us for Android to replace essentially all of your XML layouts. But they understand that we can't replace all of our layouts in one fell swoop, so they've built us very nice libraries to interoperate with Jetpack Compose, the old system and the new system. Let's see, next slide. Okay, I'm going to give you a quick overview. So I'm going to refer to the old XML view system as Android Classic, and I'm going to refer to Compose, obviously, as Compose. And I've sort of figured it out that the old system is going to be in purple and the Compose part is going to be in yellow, just so that we don't get muddled. So how Compose works is you don't code XML anymore. You code everything in Kotlin. It has to be in Kotlin. You have a function that's a composable. You put an annotation called @composable on the function, and then you can call composables inside other composables. So that's how Compose is structured. And you just declare the pieces that you want. Yes, I want a button, or I want a text element, or whatever it is you want inside this nested structure. And what's happening under the hood, this @composable, what it actually does, what the compiler does, it actually changes the signature of this function, and it puts into the signature the composer. So this is like a secret actor in the wings. The composer knows the whole hierarchy of the views, and it has data structures to know which views need to be changed and which views need to be re-rendered. And how would it know this? So one of the things about a composable is you pass in the state. So these functions, they don't change the state. They just display the UI. They just build a UI based on the state. So there's no way for them to get strange situations with the state and have problems where the UI doesn't match the state. They get the state in and they display it. And if anything like a button, like the take picture button, needs to do anything, you can define as part of the parameters some other event. In our case, it'll be take picture or on click. And this takes a body that gets executed, and this can get executed outside of the Compose framework. So what you see here, the pattern that Compose uses is that you're passing the state into the UI and that the events bubble back. This event bubbling back is this callback function. That's part of the parameters. So how does the interoperability with this work? So say, for instance, we have a layout, an XML layout, or an activity or a fragment that is in classic Android where it wants a view object. So it wants to build a hierarchy of view objects and it needs a view object. But what if I've got a compose button or a special compose view? How do I build this into a classic Android view system? So Compose has given us a compose view, which is a view just like any other view in the Android view system. The difference is that it has a method, set content, and inside the set content, you can do any compose things that you need to do. So if you've got a special button that's a compose button, you would call that function in the set content view over there. On the flip side, if you've got a whole hierarchy of composable function calls, so maybe you're building a screen and you've got toolbars and you've got buttons and everything, and in the middle of this you want to put a camera preview. Compose provides a composable function called Android View that can be called inside the structure and that Composer understands. And one of the things that Android View has is a factory method. It also has an update method, but it has for our case now, it has a factory method. And this factory method, what you can do inside this factory method is you just instantiate an old Android view and pass it back, and the composable framework will call this factory at the right time, the first time that the composable gets run or runs successfully. So this block diagram is just a screenshot of the navigation inside Android Studio. So I used navigation components to build our little sample app. I actually started off not doing it like this. I started off building the whole of the navigation in Compose. And then when I tried to build a classic fragment with the camera in, I couldn't get it to work properly. And then I reread the documentation and then I read this sentence. You can use this nav host with Compose. This is possible only if all the screens in the navigation graph are composables, which of course this isn't. So this is a classic Android view. This is a classic Android fragment and a classic Android fragment. And then I have one compose fragment. So my idea is to have side by side the camera, either in the classic way or in the compose way, just to compare how they work with each other. The other thing I did was I set the themes up so that the buttons are purple if you're in classic Android, and the buttons are turquoise when you're in, they should have been yellow, but they're turquoise when you're inside the compose world. So what did I end up doing? I took a fragment. Here we are in classic Android view system. I took a fragment, which is just any old ordinary fragment. In the onCreateView method, which is something that anybody who builds fragments knows about, this is a method that you override. And inside onCreateView, instead of inflating an XML layout, I instantiated a compose view with a set content. And this is how I got a fragment to go into to be part of the Compose framework. Then I did all the things I wanted to do in Compose, did my permissions, got my buttons, got everything ready. And so there I have a composable inside of the Android fragment. But now inside my composable fragment, I want to get at this preview view, which is again an old Android, classic Android view. So I instantiated an Android view, and part of the factory, I did the setup of this preview view. using the exact same code that Ishmael just showed us. So just to step into the code just for a second, here we have override function on create view. This is the on create view function inside the Android fragment. And then here you see I don't use the inflator or any of this. The only thing I do is I instantiate the compose view. It takes a context, and I call the set content method that I mentioned before. So everything inside of this dotted block inside here, now we are in Compose world. So we've actually just transitioned from classic Android into Compose. So what I built for myself is, okay, here's the theme. There's the Compose theme that has the turquoise buttons. And this camera compose with permission is a composable that knows how to ask for permissions, get the permissions, and then if the user says it's okay, it will display the camera through another composable. So what you can see here, you see this image capture that I'm passing in over here. So that is one of the surfaces that is instantiated exactly the same way as CameraX does. So we're passing, it's like you can think of it as a kind of a state that gets passed into this thing. And here is the method. It's the take photo method. I declared this method as part of the signature for this, this camera compose with permissions method. Okay, let me tell you one thing here, just a small segue. There is what Compose does is, I mean, this is a method, but it starts with a capital letter, which kind of confused me in the beginning. But they have coding conventions. Because these are composable units, you kind of see them as like UI units that get called inside each other. So if it returns unit, if it doesn't return a value, then there's a capital letter there. So for people who spotted that, that's the reason for that. Anyway, to get back to where I was, this is the take photo method. And here you can see what I want it to do when I wanted to take, when you press the take photo button, is I wanted to call this method, take photo, image capture context. Now this take photo method, what I actually did is I took Ishmael's take photo method, which he showed us in the previous slides. I put it in a utility, maybe passing some parameters like this. And I use exactly the same utility coming from Compose or coming from classic Android to actually do the taking of the photo. Let's move to the next screen. So now here's just a little bit of a jump in. So this is the camera preview composable. So this is after the permissions were granted. No, too fast. Camera preview. You can see there's the image capture coming in. This part that's gray, you don't have to worry about it too much, but this is just to show you that you can get hold of a lifecycle owner. You can get hold of a context inside Compose. And here's the camera provider that Ishmael also showed. And we're remembering that. And then here, this is the piece that's interesting. This Android view is a composable function. And here's the factory. And the factory in here gives me a context. And in here, we're not in Compose anymore. We're actually in a piece of code that's going to be run in the beginning of the composable, and it builds this preview view, which is exactly the same classic Android view that we saw that Ishmael showed us, and we're passing it back. And this is how you integrate. This is how you transition from being inside a composable and going back to classic Android. And now you can see that's the end of the factory method. And here, modifiers are things that you do on Compose, composable functions, and we're back inside Compose view over here. So I'm just going to zoom in briefly this Android view. It's a lot of code. You don't have to remember anything. What I want to point out is that this, all of this, is exactly the same code as what Ishmael showed us how to set the camera up. There's also set camera selectors, and there's this preview view that gets passed in over here. And here's that exact same bind to lifecycle call with the lifecycle owner and everything, and you're passing everything into the bind to lifecycle. And all of this happens inside this factory method. And there we're passing the preview view as a return parameter out of the factory method. So you ask about the permissions. I'm not going to show the detail of the code. What's important to know here, there's a wonderful library called Accompanist. There are links in the references with great examples of exactly how to get camera permissions, and you'll be able to see it in the Git repo that we'll publish with this talk. Now it's time for a demo. So I'm going to flip here. I'm going to turn my camera on, my phone on. Okay, so here's my Compose app. So now there you see the overview. Now it's purple, so we're in classic Android view. If I press the Compose button, oh, I already accepted the permissions. I wanted to show you the permissions. Anyway, so you can see there is the camera view. And if I take a photo, you can see the button's turquoise. I can take a photo and it should. There's the toast coming up, taking the photo. If I go back, now if I go into classic mode, this is classic Android, this is Ishmael's code. I have the purple take a photo button and it's the same functionality. We'll see if anybody asks me about the permissions, because I can actually show that if people want. Okay, now we're ready for questions. So that's what the GitHub repo with both of these. It's got both the classic CameraX and the Compose integrated one. There's a QR code for you to scan, and Ishmael can come back and we can see what questions we have. I can share the link of the repo. Absolutely, I can. Let me see if I can cut and paste it from here. I won't be able to cut and paste it from there. Oops, there's our references. Wait, let's escape. Escape. I can share it. Let's see.
Thank you for that. We have a couple of questions.
Okay,
in the Q&A tab. I'll just read them out.
Okay, I'm going to stop sharing and then we can just be on stage unless people want, if we need the code.
I asked one earlier on, has there been a challenge supporting camera apps for Huawei devices?
You have to take that one, Ishmael.
Yeah, so I've generally had trouble with Huawei devices for some reason, but that was even before they were doing their own thing with their OS. But we sort of haven't prioritized, at least with the work I've done, we haven't prioritized this new OS, particularly because there's a lot more you have to do. And you just basically don't have those services that you really need. Yeah, but I've actually tried using the app on one of these new Huawei devices, and the camera does work. But in general, you will face challenges with Huawei devices for some reason.
You're so calm. I would be fuming if I had to do all the Huawei devices.
There's one question here by Maya. Have you tried accessing Camera 2 capabilities together with CameraX?
Yeah, so basically CameraX leverages off of Camera 2. So you definitely do have access to some of the stuff in Camera 2 still. What I actually tried to do I couldn't find a nice way to get the supported sizes for the different resolutions available for a camera device. So you can basically use Camera code to do that, and then pass your resolution, whatever it is, whether it's the smallest, highest, or whatever criteria you have. You can then pass that on to CameraX code.
Awesome, thanks.
Oh, that's cool. So it's like fully interoperable. You can just drop down into Camera 2 if you need to, and then just come up. So, Ewald, you don't need to only build simple apps with CameraX. You can build more complex ones too.
That's really fantastic. It's covered all the bases. One last question. Can we use camera APIs for Flutter Web?
We don't know because we're not Flutter devs. We'll have to ask Sylvia, right?
I guess so. Thank you very much. I think that that question, it leads very well to talk with Flutter and Silva. Thank you very much, Ishmael and Maya, for this lovely talk. I hope to see you soon in another Thanks.
Awesome.
Thank you.